Good evening, all of you. So today is our second session, and this session we are going to solve the previous year gate questions. So let's wait for 1 or 2 more minutes so that others can also join. Good evening, all of you. I am Ayushman Bhattacharya. I am a Prime Minister Research Fellow at IIT Hyderabad. Today, I am going to conduct a live interaction session on civil engineering. This is a session 2 where in which we are going to solve the previous year gate questions of environmental engineering subject. Let's wait for 1 or 2 more minutes so that others can also join. Then we will start. Till then, if anyone has any queries, you can ask me. Let's start the session. So, today we are going to solve the uh, hardness question. A hardness concept I have already explained in my last class. Whoever has joined for the first time in this session, I will request you to please refer the first session. So let's start the question. So this question came in set 1 2022. The total hardness in raw water is 500 milligram per liter of CaCO3. The question says the total hardness is 500 milligram per liter of CaCO3. Am I audible to all of you?
Yes, sir.
Yeah. Okay.
Yes, sir.
Yeah. So the first question says the total hardness in raw wastewater is 500 milligram per liter as CaCO3. The total hardness of this raw water expressed in milligram equivalent per liter is. So now we have to calculate as in milligram equivalent per liter. So in the previous class, I have explained you what is the formula of gram equivalent weight. So with using those formula, we are going to solve this question. So for I will first write the formula. So in the previous class, I have mentioned number of gram equivalent is equal to weight in grams weight in grams by equivalent weight. Equivalent weight. How now we calculate equivalent weight is equals to molar mass by valency. So before going to solve this first question, we should know these formulas. Number of gram equivalent is equals to weight in gram by equivalent weight, and equivalent weight is equals to molar mass by valency. So let's read the first question again. The total hardness in raw water is 500 milligram per liter of CaCO3. The total hardness of this raw water expressed in milligram equivalent per liter is. So they have mentioned as a 4 question. Now first in this question we have to first find the number of gram equivalent. So that is what they have asked, right? Milligram equivalent per liter. So to calculate the number of gram equivalent, we should know the weight in grams. Here they have given weight in grams in milligram, 500 milligram. So here number of gram equivalent is equals to, so they have given weight in here 500 milligram, but always weight will be in gram. So 500 into 10 raised to a minus 3 gram divided by. So now we have to calculate the equivalent weight. Equivalent weight of CaCO3. Here it will be now divided by equivalent weight. So now CaCO3 equivalent weight will be, how to calculate the CaCO3. In last class I have mentioned equivalent weight is known as molar mass by valency. So for CaCO3, molar mass will be, for calcium it is 40 plus carbon 12, O3 16 into 3 48 divided by 2, valency Ca 2 plus. So valency will be 2. So here what I am getting, 40 plus 12 48, it is 100. 100 divided by 2. So here I am getting 50. So the equivalent weight of CaCO3 is 50. So if we keep it here 50, so basically we got, so gram equivalent is equals to 500 into 10 raised to a minus 3 gram divided by 50. So here 0, this is 10. So it is 10 into 10 raised to a minus 3 gram equivalent. Now the question is asked in terms of milligram equivalent. As of now we got the answer in terms of gram equivalent. So to take milligram equivalent, we can, this is milli. So we can write it as 10 milligram equivalent. So the answer is 10 milligram equivalent. So here A, question A is the right answer. So if anyone has any doubt in this question, you can ask me now. Is it clear?
Yes, sir.
Okay. So the basic concept in this question, you should remember these two formulas: what is gram equivalent, what is equivalent weight, what is valency, what is molar mass, and what is weight in gram. So beginning with the second question, for wastewater coming from wood pulp industry, chemical oxygen demand and 5-day BOD were determined. So for this wastewater, which of the following statement is are correct? So before solving this question, we should first know what is BOD and what is COD. What is, this is BOD and COD. So can anyone of you tell me what is BOD and COD?
BOD is the oxygen demand of organic matter, and COD is oxygen demand of organic matter and also some non-biodegradable organic matter.
Okay, yeah, correct.
So obviously COD will be greater than or equal to BOD.
Okay, okay. Anyone else? Any other student wants to add anything? Whatever Hardik said, it is correct. Anyone else?
BOD is a aerobic process and
Yes.
COD is a anaerobic process.
COD is a chemical oxygen demand. It's not an
Yes,
anaerobic.
yes, sir. We use chemical like potassium dichromate.
Yes, yes, yes. So you cannot say that is an anaerobic. You are chemically oxidizing it. So anyone else wants to add anything?
BOD is used to measure or content of organic matter in wastewater, and COD is used to measure quantity of oxygen required for this process, the biodegradable organic process.
Yeah, you have said it correct. But in that, in COD, you generally measure biodegradable and non-biodegradable both. So in BOD, while in BOD only degradable organic matter. So while solving this question, so we should know few things. So BOD, what is BOD and what is COD? So COD, it is a test. It is a test that measures. Many people are joining in between. It is a test that measures the amount. It is a test that measures amount of oxygen required to chemically chemically oxidize the biodegradable chemically oxidize the biodegradable and non-biodegradable organic matter present in the wastewater. So on the other hand, so just so so here it is a test that measures the amount of oxygen required to chemically oxidize the biodegradable plus non-biodegradable organic matter where BOD, it is a measure of amount of oxygen required by microorganism to break down the biodegradable organic matter that are present in the wastewater. Only biodegradable organic matter. So have understand. Have, so other thing is, so after knowing this concept, anyone can say that COD will obviously be greater than BOD. In question, this is correct. First is correct. However, this is a multiple answers question, multiple solution question. So here, not only A is correct, in fact B is also correct because COD can never be equal to BOD5. So is it, has everyone understood? Do anyone have any question? Is it clear?
Yes, sir.
Yeah. So let's move to the question 61. So here in this question, they say a wastewater treatment plant has a sedimentation basin of depth 3 meter, width 5 meter, and length 40 meter. The water inflow rate of is 500 meter cube per hour. The removal fraction of particles having settling velocity of 1 meter per hour is. So in this question, we have to first understand the concept of sedimentation tank. So in sedimentation tank, let's first develop the concept. So this is a sedimentation tank. Here it is a sludge zone. This is sludge zone. This is sludge zone. So it has suppose it has breadth B. This is a tank. This is breadth B. This is the length L, and it has some height H. From here. Now here in this question they are asking removal fraction of particles having settling velocity. So we should first understand the concept of settling velocity, flow velocity, overflow velocity. To understand this question, so we will first move to the what is detention time, what is overflow velocity, what is settling velocity. So we know, suppose wastewater enters here, it has to cover this distance. So obviously this is the length. So what is the detention time for horizontal flow? Time for horizontal flow will be is equals to length of tank by velocity of flow. So if wastewater is entering from here, so time of horizontal flow from this point to this point, it will be the length of the tank by velocity of flow. Simple, using simple equation, distance is equals to speed into time. We need time, so distance by speed. So now, what is the length of the tank? Length of the tank is L. Velocity of flow is Vf. So v so velocity of flow, we know that the velocity is flowing from here. So obviously this cross section we will take. This cross section is B and this is H, and water is flowing like this. So Vf will be Q upon area, where area will be Q upon B into H. So substituting this Vf to in this Vf, so time will be L upon Q by BH. So this Vf I have substituted here. So L upon Q by BH. So if BH moves in numerator, it will be LBH. It is Q. So basically, it is the volume of tank by Q. So time. So basically, time is equal to volume of the tank by discharge. Now, suppose one particle enters from here. One particle enters from here. How much time it will take to settle down? Suppose it is coming and it is settling here. So there will be so many particles in the wastewater which will have a tendency to settle down. So what will be the settling velocity that time? So velocity of settling will be denoted by Vs, settling velocity. So time of falling through height h, through height. So time of falling through height h will be, since particle is settling covering this much distance, it is here and it is covering h distance while settling. So time of height distance will be h divided by Vs. So now this is the time of falling through height h. So it is now the thing is, if a particle of settling velocity Vs, here it is Vs, is introduced at topmost point, so it is assumed to be removed if time of falling through height h is equal to the detention time. So suppose this particle is, so suppose one particle is here and it has a settling velocity Vs. So if it is settling at the bottommost point at the outlet, so that means the time it has settled from this point to this point, it is equivalent to the detention time of the flow which is flowing from this point to this point. Is it understood? Have you do anyone has any doubt till now? Likita, Nandan,
That's true.
Hardik, is it clear till now, or I should explain once more?
It's clear, clear.
Okay. What about John Mark?
Clear, sir.
Okay. Surya? So the thing is, now the time of falling through height h is h by vs. So again I am explaining this particle 1 is here. So if it is settled at the bottommost point or the corner, so that means the time taken from this by the particle from this point to this point is equal to the time taken by water to move from this point to this point. Having said that, so basically h by vs will be equal to the detention time of that liquid. Detention time of the liquid, we have already calculated volume of the tank by q. So it will be lbh by q. So if it is lbh by q, so we can write it like this: bs is equals to q by bl. This is our settling velocity. This is our settling velocity. One velocity here, it is flow velocity. The water which is flowing here, this is there we have some velocity. So water which will flow, this will have a velocity of f vf, and settling velocity will be in downward direction vs. So settling velocity of the particle is q by bl. So there is another term known as overflow rate. So we know the now concept of settling velocity, flow velocity, and the third concept is overflow rate. What is overflow rate? Basically, the overflow rate can also be thought of as a settling velocity of that particle if that particle is introduced at the topmost point of the inlet will reach the bottommost point at the outlet. So saying that, so again I will repeat, we know that this is the settling velocity. Now the other concept is overflow velocity. The settling velocity of the particle can be the particle which is entering from here, also which is so many particles will enter along with the flow. So this is also settling velocity, this is settling velocity, this is settling velocity. Now the overflow rate concept says the overflow rate can also be thought of as a settling velocity if particle is introduced at the topmost point and that particle will be reach the bottommost point at the outlet. So this the particle which is here, if it is settles at the bottommost point at the outlet, this velocity can also be considered as an overflow rate. Overflow velocity rate. So this is known as overflow rate. It can also be referred as surface overflow rate. So the thing is now, so suppose overflow.
Okay, if you calculate this overflow rate
What?
velocity, if you calculate this overflow velocity, then
Hardik, your voice is not audible.
is my voice audible?
Huh? Hello, Hardik, are you trying to say something?
Yes, yes. I was trying to say that.
Huh?
Is my voice audible?
Yeah, it's not clear though.
Okay, okay.
So, so for overflow velocity, let's denote it by V naught, and settling velocity we are denoting by Vs. So there are three velocities we are talking
Sir,
now.
you're not audible.
Okay, okay,
Yes, sir.
okay. Am I audible now?
Sir.
Sir.
Yeah. So till where you heard me, like, so from the concept we developed, there are three types of velocity. One is overflow velocity, second is settling velocity, and third is flow velocity. Now I will again repeat the concept so that you can understand better. Now coming to first flow velocity, there will be a sedimentation tank. Just so there will be a sedimentation tank. In that there will be sludge zone. This is sludge zone. So it is the height from the sludge zone till top. It is h. So the water which will flow from here to there, it is having a flow velocity of vf. However, the particle have a tendency, the particles which are present in the wastewater have a tendency of settling down. So their velocity will be vs. Now, I think these both concepts are clear: flow velocity and settling velocity. Now, the overflow velocity, we consider overflow velocity if is similar to the settling velocity if the particle is introduced at the topmost point and it settles down at the bottommost point at the outlet. This we called as overflow velocity. So the thing is, any particle having settling velocity less than the overflow velocity cannot be removed 100%. No 100% removal. So if any particle have a settling velocity that is less than the overflow velocity, there won't be any 100% removal. No 100% removal. No 100% removal. However, if particles having settling velocity greater than the overflow velocity, this shows 100% removal. Particle will completely removed.
Maybe it may escape, I think.
Where
Settling
it will
velocity,
escape?
if settling velocity greater than overflow velocity.
Uh, you are saying, can you please repeat?
The second point, if settling velocity is greater than overflow velocity, may
So
escape.
how it will escape? Settling velocity will be dying the downward direction, right?
Okay, okay.
Here, the this overflow velocity which I am talking, it is in downward direction. Is it audible?
Yes, yes. Thank you.
Yeah.
I'm clear.
So is it clear to you, Hardik?
Yes, yes.
Yeah. So now, if you are talking about escape thing, we have to relate it with the flow velocity. So this is so 100% removal. So basically, so if someone talks about efficiency of the sedimentation tank, it will be efficiency Vs by V naught. So this is the concept efficiency of the sedimentation tank. So knowing the efficiency of the sedimentation tank, efficiency of sedimentation tank is equals to Vs by V naught, settling velocity by overflow velocity into 100. So now coming back to the question says the wastewater treatment plant has a sedimentation basin of depth 3 meter, width 5 meter and length 40 meter. The water inflow rate is 500 meter cube per hour. The removal fraction of particles having settling velocity of 1 meter per hour is. So in this question they have given us the settling velocity 1 meter per hour. However, the removal fraction they are talking about. So as I mentioned, efficiency is equals to Vs by V naught into 100. Now Vs they have mentioned 1, but they haven't mentioned about the overflow velocity. How we will calculate this now overflow velocity? So V naught is equals to Q by BL. So Q they have given us 500 meter cube per hour. 500 meter cube per hour. B they have given us 5 meter and length is 40 meter. 5 into 40. So the it is around 500 by 200. it is 2.5. So efficiency is equals to 1 upon 2.5 into 100. So it will be for 0.4, 0.4 or 40%. So the question asks, so round off to one decimal point, it will be 0.4. Yes, Udita, please. Ask.
Sir, why we have taken the area as BL?
Yeah,
Uh,
BL. Okay. The thing is, here settling velocity will be in downward direction. So it will be this area, L and B. Settling, so tank, there will be tank like, so this, from here you are falling. So this area you will take. But when you are talking about flow velocity, you are concerned about this area, this B into H. Is it clear?
yes, sir.
Okay. So this will be the tank. So this will be B, this will be H, and this will be L. L is basically this one. So when we are talking about this area you are considering, this one, L into B. But when you are talking about flow velocity, this BF, then you are concerned about this area, B into H. I hope this is clear. Anyone having any doubt?
It's okay.
Okay.
So in the question, why they given the density?
Uh, so that you can use the Stokes equation. So just to distract your concept to Stokes law. Understood?
Yes, sir.
So the last question is, a 50 ml sample of industrial wastewater is taken in a silica crucible. Remember, this is 50 ml sample. 50 ml sample, just a 50 ml sample of industrial wastewater is taken into a silica crucible. The empty weight of crucible is 54.352 gram. The crucible with the sample is dried in hot air oven at 104 degrees Celsius till constant weight of 55.129 gram is achieved. Thereafter, the crucible dried sample is fired at 600 degrees Celsius for 1 hour in a muffle furnace. The weight of the crucible along with the residue is determined as 54.783 gram. The concentration of total volatile solids. So here they have asked about total volatile solids, TVS. So before solving this question, let's understand what is total solids, what is total dissolved solids, and what is total suspended solids. So, so the first I will explain you everything, then we will read from that next slide. Suppose you have a 50 ml sample. This is the wastewater, 50 ml wastewater, and suppose this is a 50 ml sample wastewater, and you have a flask, conical flask. This is a conical flask in which you have kept one filter. So this is filter, this is filter, this is flask, conical flask, this is beaker. Now, if you have added 50 ml sample in that flask, so there will be some solids which will pass, and some so when you will filter this sample, some solid will stick on this filter paper and some will pass. So now from here, this filter, whatever solids will get attached to this filter, we call it as a suspended solids, because they got separated, they got attached to the filter, because they were in suspended form. Now whatever solid has passed through the filtrate and is now in the beaker, this we called as dissolved solids. So is it clear? This much concept, I think it is clear to everyone. If anyone has any doubt till now, you can ask. So moving ahead, now we know the concept. So in this beaker, there will be total solids. Once you add it, it will be divided into two solids: suspended solids and dissolved solids. Now let's move to that paragraph. So total solid. Total solid is a material left in a sample vessel after evaporation and subsequent drying. So now this is, so I told you how to find the suspended solids and dissolved solids. So in this question they are saying, if the material left in a sample vessel after evaporation and subsequent oven drying at a defined temperature, the total solid includes both total suspended and total dissolved solids, which are physically separated by the filtration. Just now we have discussed this line. Now, if someone is interested in calculating this total solids, he can do it in this way: is total solids is equals to suspended plus dissolved solids. Or you can take this 50 ml sample, you can put it in a crucible, and you can keep it hot air oven at 104 degrees Celsius. So then this will be W1, this will be W2. So obviously W1 will be greater, W1 minus W2 upon the volume of sample which you will have taken, that will be your total solids. So let's move to the other concept. Now I hope you have understood this much. So now what is total suspense? We understood now what is total solids, the material left. So I will write the formula. So this W1 denotes, so when you have, first you will measure the beaker, a weight of empty beaker. Here, W1 denotes the weight of empty beaker. So nothing is there. W2 denotes the weight of sample with water. Weight of sample plus this crucible. W3 denotes this crucible will be there. So once you have this from W2, if you kept in hot air oven, there will be W3. So this will be the weight of dried sample plus crucible. So now if you want to measure the total solids, it will be obviously W3 minus W1 upon this. This here W1 I made some different, so I will erase this. So now here W3 minus W1, here will be the volume of sample. Now let's take with the example. Suppose the weight of the crucible is 1 gram. Example, suppose. So after you added 50 ml of sample, 50 ml of water, wastewater. If you have poured 50 ml of wastewater, then you can get W2. Now if you have dried that in hot air oven, so now you got some 1.5 gram. So total solids, how we will calculate? W3. W3 means after drying. So 1.5 minus 1 divided by 50 ml. So you will get in gram per ml. So let's move to this. So total solids, you understood the material left in the sample vessel after evaporation and subsequent hot oven drying at a defined temperature. The total solids includes both suspended and dissolved solids, which are physically separated by a filtration. Total solids is clear. Now suspended solids, the portion of total solids in an aqueous sample retained on the filter. I mentioned that there will be conical flask, and there will be beaker, there will be one filter. So whatever things will get remain on that filter paper, we call it as a suspended solid. And whatever solids present in that filtrate after filtering the water which stored got here, in this solid we called as dissolved solids. So dissolved solid is portion of total solids in the water sample that passes through a filter with a nominal pore size of 2 m under specified condition. So another volatile solid is the total suspended dissolved solids from a sample after ignition for a specified time at a specified temperature. So if you now you got this W3. So again I will explain in weight. W1 refers to the weight of the crucible, empty crucible. W2 refers to the weight of sample 50 ml wastewater sample plus crucible. W3 refers to the weight of the dried sample plus crucible. Now if you keep now if you keep this crucible in the muffle furnace at 550 around degree temperature, then the solids which are present in that, the volatile solid will escape. So this, if you keep it in the muffle furnace and after that if you weigh it, that is denoted by W4. So some solids will get evaporated. Since they are volatile, they get volatilized. Now for that, so volatile solids we will calculate by W3 minus W4 upon the volume of sample. So as it is written, the total suspended and dissolved solid lost from a sample after ignition for a specified time at a specified temperature. Now the fixed solids we call it, the fixed solid is the sample which is present in that, the sample which is present in this only, which is not volatilized, that is called as fixed solid. So the total suspended and dissolved solids remaining in a sample after ignition. So here is remaining in a sample after ignition, whereas in volatile solid it is lost from the sample. So this is the difference between volatile solid and fixed solid at a specified time. So let's understand better with this flow diagram. So this is a sample which I mentioned it as wastewater sample 50 ml. Suppose we take 50 ml sample. So this is sample here means wastewater, or you can take sludge also. Wastewater, suppose 50 ml sample. So now if you have evaporated, you have kept in a beaker, this is a beaker, you have added sample here and then you have kept in the hot air oven. Through using that you will get total solids. If you filter that sample and then you evaporate, you will get, if you filter that sample and you keep that filter paper in the hot air oven, you will get total suspended solids. Means, so from that setup, so this was the setup, this was the filter. Here evaporation, if you keep the filter here, if you keep this sample, then you will get total dissolved solid. If you keep total dissolved solid sample in muffle oven, you will the remaining, so in that the which get vaporized, which get volatilized, you will get as volatile dissolved solids and fixed dissolved solids. However, if you keep this total suspended solid in muffle furnace, you will get volatile suspended solids and fixed suspended solids. This fixed suspended solids and fixed dissolved solids will known as total fixed solids, and this volatile suspended solids and volatile dissolved solids will give total volatile solids, and total volatile solids and total fixed solids will give total solids. Is it clear? If anyone has any doubt, you can ask me. Is it clear? Udita, Likita, Sinchan, Roy, Hardik?
Yes, sir.
Yes, sir.
Oh,
Yes, sir.
okay. So let's go back to the question. A 50 ml sample of industrial wastewater is taken in a silica crucible. So, so they are saying a 50 ml sample. This is A 50 ml sample is taken in a silica crucible. The empty weight of the crucible is 54.352 grams. So basically, what they have done, this is a silica crucible. Suppose silica crucible. First, what they have done, they have noted the weight of that silica crucible. After that, they have added the sample in that. Then they have kept it in the hot air oven for drying. Hot air oven. So moving to the next question, moving to the next part of that question. So the crucible with the sample is dried in hot air oven at 148 till constant weight is achieved 55.129 grams. So they have said when they have measured this weight, they found out here the weight of the empty crucible is 54.352. 54.352. The crucible with sample is dried in hot air oven is 55.129. So here they have dried, then they have kept in desiccator, then weigh. So here final weight they have got 55.129, I think. Yeah, 55.129. So the total solid, how much they got? Total solid is A minus B into 1000. So here they have questioned us, they have asked volatile solid. So we have not bothered about total solid. Thereafter, so after getting a constant weight of 55.129 grams, thereafter the crucible with dried sample is fired at 600 degrees Celsius for 1 hour in a muffled furnace. The weight of the crucible along with the residue is 54.783 grams. So this sample, after weighing this, they have kept in the muffled furnace, and after that, after firing at 600 degrees Celsius for muffled furnace, they found the weight of the crucible along with the residue is 54.783. So here is 54.783 gram. So I think from picture it is very clear to visualize the question. So now we have two weight. First, weight of the sample plus weight of the silica crucible is given in this. They have kept in hot air oven. After that, they have measured again, which is 55.129 gram. This same sample they have kept in the muffled furnace after for 1 hour at 500 degrees Celsius at particular 600 degrees Celsius, and then they found their weight to be 54.783 gram. So for volatile solids, the formula is A minus B into 1000 per sample volume. So A is final weight of the residue plus dish and filter before ignition. So before ignition, the value is 55.129. So 55.129 minus B is final weight of the residue and dish after ignition. So B is 50. Let's do it in the next page. So from here, the 55.129 minus 54.783 divided by, so this is in gram they have mentioned. Let's check answer they have given in milligram per liter. Okay, so for gram, so and what is the sample amount? 50 ml sample they have taken. So this is the 50 ml sample and this is in gram. To convert this into milligram, we are multiplying it with 1000. Now to get the answer, 55 milligram per liter they have asked. So 55.129 minus 54.783. So this is by 1000. So divided by 1000, multiplied by 1000 and divided by 50. So C option should be the correct. 692 milligram per liter. So this will be 6920 milligram per liter. Here, if you solve it, you will get 6.920 gram per ml. since ml. So if you convert it into liter, it will be multiply numerator by 1000. To convert it into milligram per liter, this is milligram. So milligram per ml it is this now. If you multiply above by 1000 to convert this into liter, it will be 6920 milligram per liter. I hope this is clear to each of you. If anyone has any doubt, you can ask me now.
Uh, could you please once show the diagram?
Yeah, this one,
No.
this one.
Yes.
Yeah.
So here, whatever the weight, the final weight, 55.129 is there.
Huh?
This weight, uh, we call it as total solids, right?
Your voice. Can you please speak loudly? Hello.
Yes, yes.
Yes, yes. Please, please say.
Actually, the that page was so
Yes,
this 55.129 is there, right? This is total solids, right?
yes, yes. This is total solid. Yes.
And when we ignite it at this temperature,
Uh,
whatever the evaporated solids is there, no, that is volatile solids, right?
yes, yes, yes,
And the weight remaining here 54.78, this is fixed solids, right?
yes, yes, yes.
So if we want to get that evaporated
So you have
escaped
to
volatile solid, we have to remove
subtract.
this from here.
And
Okay, okay,
since
got it.
they have asked in milligram per liter, so sample volume you have to consider here.
Yes, yes. Okay, now
Okay.
it's clear. Right.
Yeah.
The way of explanation, like with the diagrammatic, is very nice. Actually,
Yeah. Thank you.
yeah, it is very clear to understand.
If any other student if any, has any doubt, you can ask me. So this is all about today's session. I will be here till 7 p.m. So if you people want to leave, you can leave. Else you can stay and you can ask me any doubts if you have.
Good evening, sir.
Yes. Good evening.
Sir, I have one doubt about website handling, sir.
Website handling means
Yes, sir. In NPTL, we have practice mock tests, sir.
okay.
In this, only showing three branches only, sir. They
Yes.
didn't enroll civil engineering
Okay.
mock tests, sir.
Okay. See, John, I don't have any update regarding that. If I would suggest you just you can mail them or you can contact them if they have mentioned any phone number in their website.
No, sir.
Yes,
Actually,
sir.
I got a mail from NPTL,
Okay.
and I replied them that we don't have any mock test for civil engineering branch. Can you let me know when will start and like that? But I didn't get any reply from that side.
Okay. Okay, Likita. The thing is, I am not related to any other programs of NPTL. So
Okay.
we are just restricted to this live interaction session. So therefore, I don't have any update regarding other issues or other matters.
Sure, sir.
Yeah.
Is it coming?
Yes. Yes, John.
Okay, okay, sir. Thank you, sir. You
Yeah.
that's showing like it will come fastly
This live
website.
session. No, no. Like the mock test which
Uh,
you are talking about.
Not sir, that website.
Uh, uh,
Yes, yes, sir.
John, I don't have any update regarding that actually. So
Excuse me,
if
sir.
you
Oh, okay, okay, sir. No problem.
yes,
Sir, regarding the question, the Celsius and the duration are just for question sake, sir.
what?
In the muffle furnace,
Yes,
they have mentioned that Celsius and all, sir. 600
six.
degrees
Yes, yes,
Celsius.
yes.
we didn't consider those.
No, we never.
Those.
We are considered. We are considering the weight. We are bothered about the weight. We don't have to consider the 601 hour thing. It is a procedure for knowing the volatile solids which are present in your sample. We are concerned only about the weight. What is after muffle furnace and before muffle furnace weight.
Okay, sir. Okay.
Yeah.
Sir, actually, in the last class, we calculated BOD for 3 days, right?
Yes. Yes.
Yeah, in that question, if we use deoxygenation constant, then it is 10 power minus k dt, right? We used e power minus k dt. If we are using e power, then it's k rate constant.
Yes.
If we
So
are using kd, then it's 10 power minus k dt, right?
last class. Uh,
Yes, sir.
I don't remember that question as of now. So just give me some time. I will like what you are telling. Can you
May,
write?
may, maybe it's regarding the conversion, like log to the basic and log to the
In that they
Yes,
base
have
sir.
10.
Yes,
in
sir.
that question they have mentioned it, right? Log some 10. I think they have specified it.
Sir, actually, in standard, we use KD to the power 10, right? If we are
Okay.
using E power, then we will use K rate constant, not the deoxygenation constant.
Okay. Yes. 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 So
But
there is a
in
convert.
last class, we used E power minus KDT.
Okay. Okay. I will check it once, Likita, and I will let you
Sure,
know by next class. Okay.
sure, sir.
Yeah. So anyone has any other doubt? So this is all for today. If you so I'm ending this session here. Likita, I will remember your question. I will get back to you in next class. As of now, I don't have that material. So in next class, I will clear your doubt. Okay?
Sure, sir, sure.
Yeah.
Thank you.
Yeah.